Hey, welcome back to Fat Mama Physics. In this video, we are continuing 5.5, interpreting graphs. Before we looked at interpolation, which is looking at interpreting the graph, what it means in between your data points. This one, extrapolation, we're going to take the graph, extend it, and to predict what might happen later on. So, given the last example with about a car traveling at a constant rate, suppose this car maintains the same average speed. We can extend the graph to predict how far the car will travel in a given time or predict the time it takes to travel a given distance using extrapolation. So what that means is we have to make an assumption. We have to assume that the car is traveling at the same rate, and it will continue to do that forever and forever and forever until whenever time stops or whatever. So because we assume that the car is traveling at the same rate, every hour the distance is going to increase by a set amount, and that is not going to change, which means the steepness of the slope is not going to change because the rate of change will be the same. And that's why we have to be careful when we do extrapolate, because we make that assumption, which may not always be true. But if it were true, we have a lot of predictive power based off of a pattern on the graph that we see. So let's take a look at what we can do when we use extrapolation. Now, when we have the previous graph, it only went up to about 300 kilometers or about couple of hours. But imagine this pattern continue. We can then take a ruler and extend this line on our graph. So notice the red line keeps going. And then because of that, we can then maybe predict how far will the car travel after 5 hours. So let's try that. Okay, after 5 hours, right here, let's see how far the car might travel. So we go up on our x-axis, and then bam, it hits there, which is, if we move over, we go over to the y-axis, that is 400 kilometers. So notice by extending the line, we can then predict what happens later on in the line that we've drawn. Okay, so after 5 hours, this distance traveled is roughly about 400 kilometers. Okay, then we can extrapolate from the time. We can also extrapolate using distance. For example, estimate the time it takes to travel 450 kilometers. So 450 kilometers is roughly up about here. So then we're going to work the other way. So let's take a look at where this line, where 450 intersects our graph. It intersects our graph right about there. So then we're going to draw a straight line as best as we could that touches our x-axis down here, which is roughly about there. Okay. Now notice that it doesn't touch the any of the lines very nicely, so we're gonna have to estimate a little bit. So here, this is 5, this is 6, in between is 5.5. So this is not exactly in the middle. It's not exactly 5.75. I think that's going to be roughly about 5.6. Okay, so that's going to, my estimate is going to be 5.6 hours. Okay, so that is extrapolating using a graph, graphically. Okay, and that's assuming you don't know the slope y-intercept form. Okay, so that's basically it. That's how you would extrapolate on the y and the x-axis, given that you've continued the line using a ruler. So I'm going to end the video for this particular case. In the next couple of videos, you will see different examples applied to real-life situations. But like I said, I will still make the slope y-intercept form of this lesson, and you will find that using the slope y-intercept form, you might be able to get a more precise answer for each of these interpolations and extrapolations, because you'll have an equation to work off of. Okay, but that will be in another video. So I thank you for watching this one. Hope you stay tuned for those examples and those slope by intercept form videos. And thank you for watching. Good luck, Fan Mama Physics signing out.